So now for some examples of finding derivatives using the new properties that we've just learned. So if f of x equals 2x cubed plus 4x plus 3x to the 1/2 minus x to the negative 2/3, we're going to find the derivative of f of x. So our first step is looking at the first term of our polynomial. So using the derivative of a constant times a function, all we have to do is use the power rule to find the derivative of x cubed and then multiply that by 2. So if we bring down the power, we get 2 times 3, which is equal to 6, and then using power rule, we have to subtract 1 from the exponent. And then the derivative of a constant times a function is equal to the constant times the derivative of the function, which in this case would just be 4 times 1, which is equal to 4. And then we have a similar situation over here. So 3 times the power, 3 halves, times x, 1/2 minus 1 is negative 1/2. And then over here we have negative 1 times the exponent, so negative 1 times negative 2/3 is positive 2/3, times x, negative 2/3 minus 1 is negative 5/3. So this is our derivative function, and this is also called the algebraic derivative, and it is pretty much the exact value. It's the exact derivative of f of x. Now for the second example, find the derivative of 3 to the power of 100. Well, we know that 3 to the power of 100 is equal to a constant, and that means that the graph of the constant would just be a horizontal line. So for the instantaneous rate of change, we know that it will not change at all, so the derivative is equal to 0.